Today we are going to study the consequences of reflection of light. To understand that, we'll do an experiment. Take an empty beaker and a stick. Place the stick obliquely in the beaker as shown and look at it from its side. You'll observe that it appears straight. Now we pour water and observe the change. As we pour water into the beaker, we will notice that the stick now appears to be bent, and this happens due to the refraction of light. To understand it more clearly, we'll try to draw a ray diagram. Now to understand the bending of a stick under water on the basis of ray diagram, what we do? We draw a container and fill it with water up to a certain level. That means we'll be showing a line showing the surface of separation of water and air. Then we'll draw a stick which is placed obliquely inside this container. Anytime you are drawing a ray diagram, your first ray you should draw straight. That means normal to the surface of separation. So we start a ray from O and make it straight. You'll find because the ray of light is incident at 90 degrees to the surface of separation, it moves undeviated. That means there will not be any bending of ray of light which is incident normal to the surface of separation. And here you please remember that angle of incidence will be 0 degree and angle of refraction also will be 0 degree. That means there will not be any refraction actually. Now the second ray will be again starting from point O and will show the ray incident at some other point on the surface of separation. Please remember, in actual, this point is very close to the first point where the ray of light is incident. But for drawing the ray diagram, we are showing it apart. So when the ray of light is incident at a certain point on the surface of separation, you'll observe the ray of light is going to move away from the normal. Why the ray is moving away from the normal? Because it is moving from denser medium to the rarer medium, from water to air. So when the ray of light is moving at a certain angle, it moves away from the normal. And when this ray is received by the eye of the person, it appears to be coming from the point I. That means if I extend this ray backward, a virtual image of the stick will be formed at position I and it will appear to the person as if the ray is coming from point I. Even though the ray is coming from point O, but it is appearing to the person as if the ray is coming from position I. The bending of stick. Due to this bending of ray of light, we find that the stick appears to be bent when placed in water. There can be other examples also, like a coin if placed under water appears to be raised. Now in this diagram also you are going to repeat the same raise. Like we'll place the coin at the bottom of the container which is represented by point O and take the first ray starting from the right hand side of the coin and make it moving straight undeviated. Because the ray of light is incident at normal to the surface of separation, the ray moves undeviated. That means the angle of incidence is 0 degree and angle of refraction also will be 0 degree. The second ray again we are going to take starting from point O and make it incident at a certain angle onto the surface of separation. So angle of incidence can be shown here, and because the ray of light is incident at a certain angle, the ray of light is going to move away from the normal. And when this ray reaches the eye of the person, it appears to the person as if the ray is coming from point I, which is actually the virtual image of coin O, right? The virtual image of coin O is at position I. If we try to find out the real depth and apparent depth from the same diagram, we can say the depth from the surface of the water, whatever the surface has been shown, surface of separation from A to point I. This is known as apparent depth, and the depth from point A to O is known as real depth. So, if you are asked to find out the relation between the real depth AO and the apparent depth AI, you can write it as refractive index of water with reference to air is equal to real depth upon apparent depth. If the same thing you want to do or explain on the basis of a glass slab, then we can modify the formula by writing refractive index of glass with reference to air will be equal to the real thickness upon apparent thickness.